Hi, everybody. Thanks so much for coming. My name is Ariel Caplan, and I'm here today to open your eyes to some powerful secrets of Ruby arrays. Now, when we program, many of the problems that we solve fall into the same few categories. We often need to create constructs like a randomizer, a 2D representation of data like a map, some kind of search mechanism, data structures like stacks and queues. We might need to take some data and use it to create some kind of a report. And sometimes we even need to do operations that are similar to those we do on a mathematical set. I want to thank my 6-year-old Emuna for finding that graphic of a set. She chose that, so thanks. It turns out that to do all these things and a whole lot more, all we need is a pair of square brackets. All we need is one of Ruby's audacious arrays. So I'll tell you about all that, but first I want to talk to you about CatWalk. What is CatWalk, you ask? Well, it is a game. It's not a game you've ever heard of because I made it for this talk. So it's just a regular Ruby file. You run it rubycatwalk.rb, and you're a cat, and you're walking through this complicated world, gathering various items that increase your score. You can see the world is circular, so it kind of loops back at the end, back to the beginning. If you will hit a turn block, you're going to see the world is going to turn by 90 degrees. So you're basically turning left. And there's various items like you see the bird head, 2 kinds of birds that they're score multipliers, so they're not scoring items, but they'll increase your score if you do grab a scoring item. And there's cyclones, which just mix up the whole world, get you a whole new layout. And there's also the sneakers. What the sneakers do is they will make the game go faster, so kind of like a running thing. But you might get bored being a cat after a while. So if you type in tiger, you're a tiger. You can also be a frog, so there's cheat codes, right? You could be a whale, which makes a ton of sense, running through an empty field, or back to a cat. And when you hit Q, you will exit the game, and you'll get this lovely tally of all the things that you collected during the game, and of course your final score. So that's the game. It's on GitHub. Don't look it up right now. You can look it up after the talk, but it's on my GitHub, amkaplan/catwalk. And you're going to see in that game how I've used a lot of the tricks you're going to see in this talk to actually implement the game. Speaking of my GitHub and me, so hi again, I'm Ariel Caplan. I've been a Ruby programmer since 2014. The slide says that I'm a backend developer at Cloudinary. Since I made that slide, that's no longer true. But they were my employer during the entire time that I put together this talk. And I have a lot of gratitude to them for, aside from my 3 years there, for giving me the opportunity to put this together. So that's why they're on all the slides. You can find me online at amkaplan. And of course, my personal site, amkaplan.ninja, where at some point the slides for this talk will be posted. A bit more about my new employer in a bit. But you're not really here to hear about me anyway, right? You're here to hear about arrays. So let's talk about the basics. What is an array? So at its most fundamental level, an array is an ordered collection of values. Those values can be any Ruby object, so you can have an array that actually even combines different types, strings, symbols, numeric types, active record objects. The sky's the limit. Very, very difficult for those who are working on types, as you may have heard in some other talks. You can get and set by index, and note that indexes are 0-based, so the first element is index 0, second index 1, etc. Most of the time, if you're creating an array directly, you would use the literal syntax. So you have pair of square brackets, number of items delimited by commas. Note that there is technically an explicit syntax where you call array.new, you give it a length and what you want to fill it with, and that technically works as well, but don't use it. No one's going to know what you did. So you can also set by index. So you can say use this square bracket equals notation. So I want to say that the element index 2 should be the string val2. Now when you fetch, a lot of people don't realize this. You can actually fetch in a more strict way. So I want the element at index 3. If there is no index 3, the array is not 3 long, then it'll raise an index error. So useful thing to know if you find yourself accidentally reaching outside of the array and getting nil. But most of the time in most programs, what you'll see is a square bracket syntax. So you can pass in an index, first of all, and it'll get whatever's at that index. If not, it'll just return nil. You can pass a range. So get me everything from index 1 to index 2 in this case. I would have done more, but I just wanted to fit on the slide. You can also use negative numbers for indices. So rather than counting from the beginning of the array, you can count from the end. So -1 is the last element, -2 the second to last, etc. And of course, there's the first and last. So kind of a more semantic way of referring to those positions. You can get some descriptive information out of the array. So what is the size and is it empty? Now note that an array with 10 nils in it is not an empty array, right? An empty array means that there are 0 elements. So it's basically like, is the array size equal 0? Okay, that was pretty basic. Probably a lot of you already know that. Let's move up a notch. So let's talk about adding and removing elements. So in Ruby, you can add and remove elements to the front and back of the array. Let's say we have an array with 5 integers, 1, 2, 3, 4, 5. You'll note that I'm going to use integers a lot in this talk. It's not because I have a special fondness for integers. I think it just makes the examples really easy to understand. So if we want to add items, we can add on to the beginning or the end. We can use the push method or the shovel operator, which is the double less than sign, in case you're not familiar. Those are just basically the same. You're just adding an element to the end of the array. So we push on the 6, we shovel on the 7. We can see the array has gotten longer. We can also unshift to add to the beginning. And we can see that we've added our 0 to the first, well, before the first index, so that's the new index 0. And basically everything in the array has now been bumped up by 1 index. Okay, we want to get rid of items, so we can get rid of items from the end using the pop method. So that'll pop off the 7, and we can see the array has been reduced in length by 1. We can also shift to remove an element from the beginning, and now we see that our 0 from the beginning is gone. That already is enough information to start building some data structures. So stacks and queues. Stack, just as a reminder, is a last in, first out data structure. So we add in items and then we remove them in the opposite order that they were added. So actually, like we barely even need a stack class, just push and pop. Push is push and pop is pop. So we create, just to show kind of a visual example, we create a stack. We can push on the symbol A, we'll follow it with B, and finally C. And then when we pop off elements, we're just going to remove them in the opposite order. So C, B, and finally A. Okay, very, very easy with arrays. For a queue, so we would most likely use push and shift. So push is still push as before. We're adding on to the end, and shift will remove elements from the beginning. So we create a new queue. We're going to push on A, B, and C, and then we're going to remove elements in the opposite order, right? Kind of like a regular queue, any kind of queuing system is going to work. So the first element disappears, finally the second and the third. And we're doing that by shifting elements off the beginning. Now, you might be seeing this and thinking to yourself, like, wait a minute. Isn't it kind of arbitrary? You're adding on to the end, taking off from the beginning. Like, could we do the opposite? Could we add items to the beginning and then remove them from the end? In a certain sense, that would kind of make more intuitive sense, right? Whoever's at the end is always getting removed first. So it's a good question. The answer is like yes and no and maybe, kind of all in one. Let's break it down. So there's this article, Ruby's Missing Data Structure by Pat Shaughnessy. You may have heard that name. He wrote a book called Ruby Under the Microscope, a very popular book about learning the internals of Ruby. And in this article, here's what he explains, and then I'll explain what was a little bit missing. So an array is represented inside of Ruby as a contiguous set of addresses in memory. We have a pointer at the beginning, and we can start filling up with elements at those addresses. Now, what do we do if we want to have a queue in the manner we described? Well, we can push elements onto the end, and we can remove an element from the beginning. What we would do is we remove the element and just slide over that pointer. So that's a pretty simple thing to do. Let's reset it to how it was before with A, B, C, D, E. Let's imagine moving the opposite direction. Well, taking elements off the end is not a big deal, okay? But what about adding an element to the beginning? Like, where do we put it? We don't have a box for it. So what we actually have to do is find a whole new place in memory that has all this open space, move everything over, shifted one to the right, and then the pointer will remain at the very beginning, and we can finally put in that new element. And that's kind of expensive to be moving around memory all the time. But note that the difference between the beginning and the end is that at the end we've reserved all this space. At the beginning, we haven't reserved space. So there's nothing fundamentally different about the end versus the beginning. It's just an implementation detail of where do we reserve space at the beginning versus the end. Now, I don't believe in dishing out performance advice without providing benchmarks. So I put together a benchmark. And so the benchmark basically either unshifted a bunch of times to add elements to the beginning of the array, or we use push to add elements to the end of the array. And it turned out the performance was exactly the same. So this was annoying. not what I was expecting, and I had no way of understanding this, because like this is the conventional wisdom in the Ruby community. Like you don't use unshift. No one uses unshift, because everyone knows that it's bad, but it's fine. So, little story. Back at RailsConf this year, I met this guy, also this guy, right here in the audience. So Ufuk works at Shopify, and he's also a speaker at this conference and was at that conference, and we got to talking, and suffice to say that I now work at Shopify. So I'm just gonna wear my Shopify gear now, so I can be formally representing Shopify. But I said, pretty soon I'm going to be working at Shopify. Like, why don't I just get in touch and see if he can help me? Because like they have a bunch of people who know Ruby stuff, and he was more than happy to help out. So called in Peter and Kevin, and basically we got to the bottom of this, or they got to the bottom of this, and then I was able to just kind of put on my slides and take credit for it. So yeah, it turns out there's this feature in the Ruby language bug tracker called array as queue. This is a solved problem as of 9 years ago. It was released in Ruby 2 in 2013. So what makes me really sad is that the article that I think a lot of people have read in the community, Ruby's missing data structure, that I referenced earlier, which is the one that kind of popularized this idea, as far as I know, that unshift shouldn't be used, was published after the release of Ruby 2, just a couple months. It could be it was written before and then published after. I don't know the whole history, but it makes me very sad. But if you really want to impress some like very, very senior developers who may not be aware of this, you can use unshift in your code. When on code review they say, wait, you can't use unshift, it has bad performance, you could be like, benchmark it. And then when they're like, wait, what's going on here? You can point them to this talk. So I just make sure that that's the kind of thing that would be well received in your team before actually applying that advice. Okay, so since I work at Shopify now, I feel like this is like the Shopify sticker sheet. There's some good stickers here. I'm just going to start adding them to my outfit while we go through the piece of the talk. So now we're up to the next section. I'll add one sticker, order and randomness. So we can create randomness in Ruby using arrays. If we have an array, first of all, we can just like shuffle it up, get a whole new order if we'd like. And as many times as we do it, it'll use what's called a Fisher-Yates shuffle under the hood, a pretty standard computer science algorithm in order to do the shuffle. We can also get one random element from the array by calling array.sample. And actually, if we want a few items, we can call sample with an argument. Now, a little bit of a word of warning here. So sample with an argument is not the same as calling sample 3 times. If you call sample 3 times, you may get the same element 3 times. If you call sample with an argument, you will always get different elements. And actually, just as a what's it called? An illustration of how far this goes. So if you call sample with an argument, let's say this array is 5 elements. So if we call with sample with 20, we'll actually just get a 5-element array back. So you may not even get the size that you requested. So pros and cons of the 2 options, just something to be aware of. If you want to clean up the array, so you've made a little bit of a mess with your shuffle, that's fine. We can just call .sort, and we'll be right back in order. It uses, I believe, quicksort under the hood. Now, you might want to sort by something, not directly comparing the elements, so you can actually pass a block and call sort by. And so in this case, we're sorting by the negatives of each element, and so -10 is the smallest, -1 is the largest. Now, when might this be useful in real life? Let's say you have a bunch of, for example, active record objects. You want to sort them by their IDs. You want to sort them by their timestamps. You want to sort a bunch of products by their prices. These are all things you could easily do with sort by. Now let's say you want to have all the elements mixed with each other a little bit. So we have an array here. We just are going to use a 3-element array. You'll see y minus x. So we have the combination method, which lets us, in this case, we've said every combination of 2 elements. And so we get all different combinations of 2 elements. We can also call the permutation method. And I realize some of us may be a little fuzzy on our high school math. So just to make sure that we're aware of the difference, permutations care about order. So 1, 2, and 2, 1 are different permutations. But combinations don't care about order. So they will be the same combination. And the way to remember this, I actually just saw this like yesterday. A combination lock is actually a permutation lock. Think about it. Okay, so let's move to a more practical example. Let's say you have an online store and you want to display related items, like customers who purchased this also bought blah blah blah. So for a particular element or item in your store, you have a bunch of related items, and you can just kind of sample 3 items, and you're guaranteed to get different items, right? Remember the sample with an argument, you'll always get 3 different items. Don't use sample 3 times. You might end up with like pillow, pillow, pillow. That would be not good. You want to make sure you have like sofa, pillow, cushion, or something. Pillow, cushion, is that the same thing? I feel like no, they're different. But let's say you want to do a more scientific approach, right? You want to say, I want to look at all the different ways of combining these items. I don't know, maybe chair, sofa, bed will perform better than bed, sofa, chair. Like I have no idea. I want to try all the different permutations in equal numbers. So we can create an enumerator. We can just call permutation and followed by cycle. And what it'll do is it'll create an enumerator that will, when you call next, every single time it'll give you another permutation. And when it gets to the end, it'll just cycle back to the beginning. So it's this infinite enumerator that goes around and around. And so every time you call next, you'll get a new permutation. And basically, if you have like thousands of requests going to the same server, eventually, in the long run, each one will get equal airtime. You can see what pushes product. Okay, now you might have thought that was a little dense up until now, but get ready for like the really dense part of the talk. Also, I'm reminded I have to put on a new, I'm not sure what this is a logo for, but let's talk about interpretation. So the first thing to realize about arrays is, I'm sorry, I forgot to mention, so this is a thinking cap. That's why I put this on. So really get ready for our dense part. So array includes the enumerable module. If you're not familiar with it, it's this module. It's included in a number of different classes. It's included in enumerator, in hash as well. And it basically provides very, very good tools for iteration, introspection, selection, and extrapolation. That is a lot of text. Don't bother reading it. We'll go through them one by one. Don't worry. Okay, iteration. The most basic thing this was probably one of the first things many of you learned about Ruby, is each, right? So we just one by one go through all the elements of our enumerable, or in this case, our array. There are also some more complicated methods like each slice. There's also each cons, each pair, a few like that. And in this case, rather than yielding them one by one, it will yield them, since we said 3, so it'll yield them 3 by 3. All right, let's move on to introspection. That just means we basically ask the array a question about itself. So like, are all of your elements odd? There's all, any, some, one, none, a whole bunch of different methods like that. They're all very useful. Okay, selection, focusing on the things that are of interest to you. So you can use a select method to say, I don't want everything here, I just want the ones that match some particular criterion. And if you don't really need all of them, you just need one. So you can use the find method. It'll find the first one and then return. So because 4 is earlier than 5 in this array, it returned 4. Finally, extrapolation. This is where it gets pretty intense. So there's the map method where you define a transformation. You say, I have my input array. I want you to apply this transformation to every element of the array and then give me the array of what comes out. So in this case, we're just multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. But sometimes we don't want to create a new array of data. We want to create a single value. We want to come to some kind of single value conclusion from the array. And kind of the baseline method, unfortunately, it's very hard to understand, but it's a really important one, is the inject, also known as reduce. So the idea is you start with some kind of a value, in this case, just the string start, and then that's going to become what's called the accumulator, okay, or accum for short, because text size, slides, etc. We will pass that in along with the first element in the array, and we'll run the block, and then the result of the block becomes the accumulator for the next round. So we start with the start string. The first round we'll add on space A, next round space B, next round space C. Okay? But what's interesting about this, and I really want to focus on, is that the end result is not an array. It's just one single value. And what we're going to talk about now is a few other more specialized things that you could basically imagine implementing using inject, but ultimately collapsing the array to a single value. Okay? One great example is minimum and maximum. So you have an array of values. You can find the minimum, the maximum, or the min-max, which will just in one pass find both. Note this is not just for integers, not even just for numeric types. You can do it with strings. Anything that's comparable, you can find the minimum and maximum. So this is just the earliest and latest in the alphabet. Let's say you want to collapse it in the sense of summing all the values up to one value. So you can use a sum method. In this case, we're just summing up all the integers. And some will even take a block. So you can say, don't sum up the things themselves, but actually apply some kind of a transformation, and then sum the result of that. So in this case, we're summing not the integers themselves, but the squares of those integers. Okay, now where might this be useful? So let's talk about a shopping cart. That's probably an example we can all relate to. We've all done online shopping. So we have a shopping cart with several items. Each is represented by a hash with a name and a price. And finally, the shopping cart itself is just an array of arrays. Each subarray is an item and a quantity, right? Think about a shopping cart with like, I have this many of this, this many of this, this many of this. Okay, that's what we have right here. Now, let's say we want to display a little graphic of here's the item you have the most of in your cart. So we can say you can use the max by method, which is similar to what sort by does to sort and what sum with a block does to sum. So max by will do to max. We can say the max by the quantity. I don't want you to compare the whole array. Just look at the quantity piece of each subarray. So find the thing that there's the most of, and then pull out the product itself and look at the name, and we get milk because there's 3 milks as opposed to 2 catnips and 1 hat. If you want the most expensive item, we just change the block. So rather than maximum by quantity, you want max by product price, and we get the hat, which is far more expensive than anything else. And if we want to get the order total, we can use sum with the block. So for each element, multiply the product price by the quantity, and we have the total value in the cart. Let's move into the second dimension. Some of you are wondering how many pieces this talk has. Let's talk about arrays as maps. We're going to use this array of arrays with integers. I found it, just for me, it's visually easy to see. If it's not for you, then I'm sorry. But basically, if you have a map, you might want to move it around, reorient it, flip it, stuff like that. So flipping is pretty easy. We just reverse the array. That's for what I've arbitrarily defined as a vertical flip. You could technically think of it in the other direction. But vertical flip and horizontal flip is just you reverse each individual subarray. Okay, what else can we do? We can transpose, which is basically an exchange of the rows and the columns. You can think of it as we have that across from the top left to the bottom right, the 159, that stays in place, and then we flip around that axis. So that's built in, but we can do some interesting things with it. So if you transpose followed by a reverse, as you see on the top right, we've rotated the entire thing 90 degrees. And if we do transpose map reverse, right, the other kind of flipping, we've rotated 90 degrees in the other direction. So that's pretty useful, actually. We also have a rotate method, which is not that kind of rotation. It's a different kind of rotation, more like if you think of an on-call rotation. That's really what it's about, right? It's, someone gets to the top, they get sent back to the bottom of the list. So rotate will take the first element sent to the bottom. There's an implicit argument here of 1, by the way. So if you do -1, you'll actually send from the end to the beginning. You can do multiple steps at once if you want. You can rotate 2, and it'll send 2 items to the end. Same thing for the negative as well. So here's a thing that I did recently. You don't have to read all the code. There's only one line that matters. But I was solving a puzzle for a code challenge, not for production code, where I had to take a puzzle, basically a bunch of puzzle pieces, and figure out how to fit them together, kind of like a jigsaw puzzle. And so you imagine you want to rotate the pieces. So you can see on the bottom of the very long line, I use this piece.transpose.reverse trick in order to rotate it. And, you can rotate it 90 degrees, 180, 270. I can't bend my arm that far. And that way I got all the orientations and was able to solve a puzzle. So let's move on to search. One thing you might want to do very frequently is autocomplete. Okay, and it turns out that we don't need anything too fancy for this. Ruby actually provides something really nice we can use for autocomplete. May not be the right solution in all cases, certainly isn't, but just a cool thing that Ruby can do out of the box. So imagine we have a bunch of cat breeds. We're storing them in memory, and the user has some kind of input, right? They type in the letters PE. We want to know what they're talking about. So we can, first of all, regex.escape, make sure that we're treating user input as literal text. We don't want them to do some kind of regex attack and crash our servers. But once we've turned that into something that we can put into a regular expression, we can use the grep method. And the grep method will search through the array for any strings matching that regular expression. Now, just note we're using the I flag for case insensitive, which I think makes sense in this context. Now, you might look at this and say, well, I don't want European shorthair, right? I just want things that start with PE. Okay, so change the regular expression. Start with a \b, beginning of a word. And you might say, well, I don't want that last one, right? Because it's from the end. Okay, so use the \a or capital A instead. So just the beginning of the string, right? You can play around with the regex, figure out your own rules for autocomplete. And again, this is not necessarily a good solution if you want to do fuzzy autocomplete and things like that. But it's just a cool thing to think about, that Ruby has everything you need for like a really, really basic autocomplete out of the box. Note that there's grep as we described. There's also grep v, and they're like the opposites. So grep is everything that matches the expression. In this case, we have regular expression just looking for a space. So multi-word cats. And then grep v will do the opposite. It'll look for anything that doesn't match a regular expression. So single word cats. Okay, another thing we have to do a lot is finding the first. So imagine you have a bunch of orders, and they're all they're sorted and by date, and we want to find the first order from the current year, 2021. So I mentioned before we have the find method, right, where we'll be able to find the first one. Now what it's doing is it's starting from the beginning, checking, does it return true or false for the block? It's going to go through till it finds a value that's going to return true, and that's what it's going to return. Okay. However, there's another way you can do this using bsearch, and bsearch is very dangerous. So be very careful before you use it. That things are sorted in the exact way that it wants you to sort them. But the idea is you give bsearch a block, and you should have everything from the beginning of the array return false for that block up till a certain point, and then it flips to true, and then from there till the end it has to be all true. Otherwise, this is not going to work. But in this case, this is a perfectly valid usage of bsearch. It'll start in the middle. Okay, it returned true, so we're basically gonna bisect. B is short for binary search. So we're gonna bisect the entire thing, starting from the middle, and then basically whether it's false or true will determine whether we continue to bisect upwards or downwards. So this is true, so we're gonna bisect up. We're looking for the first false. Okay, we find a false, so we're gonna bisect down. And finally, we end up on this element, which is the first true, right? We're looking for exactly that false-true boundary, and it'll return the same value. Now, why would you want to do this? So let's say your array is very big. Let's say you have an array of 1 million items. Find might go through all of them, right? That's a lot of CPU cycles. bsearch will go through about 20. So that's a lot less than 1 million. Binary search is really good, but only if it's sorted properly. Okay, now let's say I want to get everything from the current year. So what I can do is I can do bsearch index, which rather than returning the element itself, will return the index, and then I can use brackets with a range to get everything from there until the end, right? -1 meaning the end of the array, and it'll just get me that section of the array. Okay, time for the crowning achievement. Sorry, that was loud. The crowning achievement of arrays, in my mind, is the ability to use arrays as mathematical sets. So we might have an array, you might have some duplicates, that's fine. Sets are generally, they only have one of each item. You can uniqueify the array using the unique method. So that's pretty nice. You can also use set subtraction. I don't know if it's technically called set subtraction, but basically it'll remove anything in the array that is matching any of the elements in the array that you're subtracting. So there's multiple twos. You don't have to say -22333. You just say -2 3, and it'll remove all the twos and all the threes. Now note that it does not deduplicate the array that you started with, so we still get multiple ones, but it's subtracting in a set-like fashion. But wait, there's more. Let's go deeper down the rabbit hole. We have set 1, 1, 2, 3, set 2, 2, 3, 4, 5. Okay, they're technically arrays. There is a concept in Ruby called set, by the way, so I don't want these things to get too confused. This is just set-like behavior of arrays. Okay, so we have two arrays that are kind of like our sets, 1, 2, 3, and 2, 3, 4, 5. We can look for what are all the elements that are in either of the sets. So we'll just get one of each element, whether it's in one set or both sets. We can also use the ampersand operator to get the overlap between the sets. So 2 and 3 are in both sets. 1, 4, and 5 are just in one or the other, and so they don't come out in the results. Where would this be useful? Turns out it's actually very, very useful. Here's one example taken straight out of Active Record. So if you have an author with a bunch of posts, you want to replace them with some other posts. And we'll just call new post array the post that you want it to now have, and the current posts are what it had before you did the replacement. So first we're going to reload the intersection between the current post and the new posts, because we just want to make sure that nothing's been like deleted in the meantime, or changed or whatever it is. And then we say, okay, so delete all the posts that are currently there, but we don't want to be there afterwards, and insert anything that's in the new stuff, but not in the old stuff. So these operators are really, really useful in these kind of contexts. I mean, I've used this stuff in caching situations, and there's lots of ways these are useful. Okay, so that was like the main body of the talk. Let's just review what we've covered. Arrays are indexed collections of elements. We can randomize and sort them. We can iterate or interpret one by one or together. We can use two-dimensional arrays as maps. Arrays have rudimentary search capabilities. It's not Elasticsearch, but there's some pretty good stuff there. And we have this set-like functionality. Okay, now I want to offer you an option. Choose your own adventure. But it's like a personal option, okay? On one hand, the keynote's coming up, and if any of you want to leave, that's okay. I realize that I'm at time. There is more talk. I'm going to talk about CatWalk. So if anyone wants to run to the keynote or run to the bathroom or something like that, totally cool, no hard feelings. I'm going to just go for a few more minutes explaining how the ideas that I presented up until now are used in the CatWalk game. I have to add one more sticker. So first of all, the map. Okay, how do we generate the map? So I created this array of map items. Basically, the number of times something appears in that array represents the probability that I want it to appear for any particular location. And then we just use sample for the number of rows that we want, passing in as an argument the width of the game board, and we get a nice random map array of arrays. Okay. What about shuffling when someone hits a cyclone and everything goes a little bit haywire? This is the code that's running. I think it's easier to understand with an example of just a 3x3 array. So we first flatten it out into one single array. We use shuffle just to mix it all around. And then we use each slice to restore it to being an array of arrays. So we get back just a new combination or permutation, I guess, of the map. Okay, so that's exactly what's happening here, right? Take it, flatten it, shuffle it, and then bring it back into different rows using each slice. Map movement. Okay, so we saw that the map is moving a lot during the game. What is the current symbol that you just walked over? If it happens to be a turn block, so use our transpose map reverse trick to rotate everything by 90 degrees. Otherwise, we use rotate. So on each line, we'll just take the element at the end and send it to the beginning. I think I said that right. And that's why the world, kind of continuously, right? It's a looping world. For the controls, so you can move up and down. So moving up means just move the map down, and down means move the map up, again, using rotate just to send a line to the end or a line to the beginning. Tracking active items, this was like the most interesting piece of it. Don't worry about reading all the code. I'll try to explain it graphically. We have this array of temporary items, right? Items that last for some period of time. We want to basically identify which are the ones that are still active. And so we could theoretically just look through that array and say, okay, which items are active? Use select. That won't scale well if someone plays for like several years and has hundreds of thousands of items, which I guess is not that practical. But it was basically a good excuse to use the bsearch index trick. So I figured let's use bsearch index, look for items that are active. And by the way, active is determined based on when it was acquired and what's the current time and how long is the item supposed to be active, right? Bsearch index find the most recent active or the oldest actually active item, and then grab from there until the end of the array. Here's why that doesn't work. So here's our timeline. Here's when everything was acquired. Our current time is on the right, that dotted line, and here's how long each item lasts. So let's do a binary search. Okay, we start in the middle. Our cyclone is no longer active. So we're going to bisect to the right. The sneaker is active, so we're going to bisect to the left. The duck is active. So we found our false true boundary. Everything to the right is assumed to be active, and the cyclone is not active. So that's not very good. we're going to have the cyclone just like running for far too long. Okay, next attempt. Let's just add a select active to the end. We're going to get rid of anything that's inactive. So our same setup as before. Let's see if this is going to work. Okay, we start in the middle again for our binary search. That's still active. Move to the left. Our cyclone is inactive, so we're going to move to the right. The bird is active, so we found our false true boundary. Everything to the right is assumed to be active. It's true that the cyclone is not active, but that will be removed by our select active, so that's fine, right? But what about to the left? We now have a false negative, right? Because the duck is still active, but we haven't found it. So basically, the reason this doesn't work is because you have to have exactly that structure where, for your block, right? Everything is false up to a point, and then it becomes true, and it's true till the end. So I couldn't really use binary search here, even though I wanted to. I ended up just using binary search by the actual timestamp itself, basically saying what's the oldest possibly active item, and then just do a select from there to the end. Don't read all the code. It won't make any sense to you without the context. A few other miscellaneous things. We have multiplicative items. So I have multiple score boosters, right? I have a ×2 and a ×3. I end up with a ×6. That was implemented very, very easily with inject. For the cheat codes, where you can change your avatar, so I have a queue-based keylogger. So every time you hit a key, it adds it to a queue, and then we can just check the last few elements on the queue to see what's, did you just enter a cheat code or not? The final score uses tally, which is a method that I did not mention, but it's a really nice one. It gives you a tally, right? It says here's all the items in your array, and here's how many of each there are. You can check out all the code on my GitHub again, amcaplan/CatWalk, if you're really interested to see some uses of these methods. The last thing I'll leave you with is a really nice one-liner for an appreciation circle. So the idea is that basically you get your whole team into a circle. It could be virtual or it could be in person, whatever works. And everyone has to express gratitude or appreciation for the person to their right or to the left, depending on how you decide. I think this is to their left in that graphic. So there's a little one-liner you can use if you're in a virtual space to do that. This happens to be like the most recent team that I work with, the people there. And I actually did this with them, and it was a really nice exercise. So your homework is basically to figure out how that's working. A lot of really nice methods there on arrays and enumerables, but it works, and you can use this with your own teams. So with that, I would like to start my own appreciation circle. I would like to appreciate you for being an amazing audience, and you can appreciate me by applause if you want to.